In the future, robots will transform everything. In Morpex, we believe that anyone can be part of this transformation, and that's why we designed the Moonbot.
You can use the Moonbot kit to create the 3 official robot forms. Now, first is the Moon Rover. This is an autonomous, moving platform that's great for transport. Then you have the Moon Mech. This is a flexible robotic arm that is great for grabbing things. And finally, there's Moonbot. Moonbot is a cute little robot with a lot of emotions. Now, the translucent shell allows you to see the electrical and mechanical parts inside of each robot, as well as its status through a set of LEDs.
Unlike other robot kits, Moonbot uses cutting-edge computer vision as its primary sensor.
By building, modifying, or even hacking the Moonbot, everyone can learn how to use the AI technology.
The Mu Vision Sensor is the artificial intelligence core of the Moonbot kit. This tiny module integrates many image recognition algorithms like color recognition, line detection, ball detection, human detection, and card pattern recognition. These algorithms let your robot see the environment and do fun things based on what it sees. The Moonbot kit supports all the programming environment that is compatible with Arduino. You can do it either on PC or on mobile devices like an iPad. The controller has 15 connector ports, which provide a multitude of module combinations, making it perfect for robotics education. The Moonbot kit will provide 8 well-designed electronic modules and will support more with future updates. The controller also supports third-party modules that are Arduino compatible. With generic mounting holes designed for adding whatever you want, whether it's metal, cardboard, even Lego pieces. Whether you're 8 or 80, you can make something amazing with the Moonbot kit.
Hi, I'm Joseph Schlesinger.
And I'm Connie Hugh.
And this is Sparky! Sparky is a simple-to-use, open-source, Arduino-based robot. The lowest-cost full-feature robot on the market. And is an engaging introduction to programming, electronics, and robotics.
Sparky is very easy to use and to get started with. Just take it out of the box, plug it in, download our customized Arduino software, and get started with any of our dozens of programming samples. Or you can write your own code in minutes using our online tutorials. We've been conducting pilot classes with elementary and middle school students and have been amazed at what they can do. We are working hard on enhancing and expanding our curriculum for Sparky, improving the lessons and code used in the class. Sparky is easy to use for the beginner.
Yet feature-packed enough for even the most passionate enthusiast or researcher, and is aimed at anyone looking to learn these subjects or to have a comprehensive robotics platform for their own projects and experiments. Sparky includes a servo-mounted ultrasonic distance sensing head, 3 light level sensors,
A 3-axis accelerometer to detect the current angle of the robot, 5 line following and edge detection sensors,
infrared send and receive modules for inter-Sparky communication, and to use with the included remote control, a 128 by 64 pixel graphic LCD.
and 2 geared stepper motor wheels for highly precise measured movement, which, when combined with Sparky's center-mounted marker holder, allow you to do some amazing drawings.
If we raise enough to reach our 200K stretch goal, we will include a multi-channel data radio, perfect for coordinating multiple Sparkies to swarm robotics.
Sparky's durable ABS plastic construction, same plastic used in Legos, will also be made with a special textured injection mold technique so that you can easily draw on it with markers.
Simply put, you can have Sparky do anything you've ever wanted a robot to do for you. Thanks to our last completed and fully shipped Kickstarter, we've demonstrated the experience in sourcing, distribution, and manufacturing necessary to complete this project.
It's also given us the time to develop Sparky for close to a year, through an evolution of dozens of prototypes, and working with our manufacturing partners to refine our current version for months. And as always, in keeping with Artbotics' open source philosophy, all designs for the robot will be released online.
Kids love technology. They all know how to use it, but they almost never know how it works. We wanted to break open these magic devices and let kids build their own stuff with technology. That's why we developed the Build Your Own Robot Kit. With Bjor, kids can use the magic of technology to build their own interactive robots, devices, or works of art. It all starts with the EasyBoard. It's the brain of the robot. On the one side it says input, on the other side it says output. The input parts are blue and the output parts are green. If you connect them on the opposite side of each other on the EasyBoard, they will respond directly. There are different input parts like a sound sensor, a rotary knob and a distance sensor, and there's also different output parts like 2 different motors, a buzzer and an LED. Bjor turns their interaction with technology into a fun, educational and creative experience. You can create anything you want with Bjor, but sometimes it's scary to start with a blank canvas. That's why we created the Craft Kits. They're the ideal kickoff to your creativity. The Craft Kits are created from pre-cut cardboard that you can assemble yourself using an instruction manual. It's still cardboard, so you can attach all kinds of stuff to it and make it your own. The EasyBoard runs on an Arduino chip, so when you're done building, you can dive into the code and make a robot respond exactly the way you want. Kids constantly surprise us with what they can build with Bjor. Together, we can find out what this new generation can build if they have the tools to build with technology. Their creativity is endless and I can't wait to find out what they will build next.
In 2003, 2 robots named Spirit and Opportunity were loaded onto a pair of Delta II rockets. The rockets blasted off separately about 3 weeks apart. 7 months later, the pods arrived, streaking through the Martian atmosphere, containing perhaps the most complex and advanced robots ever created. The rovers were powered up, stretched their legs, and made contact with their controllers on Earth to begin their long missions on the Red Planet. Today, we're proud to share our newest creation, the Spirit Rover, a desktop version of the famous rover sent to Mars. Our miniature version of the real thing is built around a Raspberry Pi computer and includes an Arduino-compatible processor along with a ton of sensors and smarts. Whether you're new to programming or an experienced pro, Spirit is a perfect robot platform for learning to program in Python and C, as well as learning the inner workings of the Linux operating system. Tutorials and lessons will guide you along the way. You'll code and control your own rover missions while learning how computer vision and autonomous robots work. Remote control your missions using Wi-Fi from a computer, tablet, smartphone, or a game controller. Spirit is an ideal platform for teaching in classroom environments, playing on your own at home, and even used in serious research. We've combined the most common pieces of hardware available in the open source and maker community into a single robot that's endlessly hackable and expandable. Not only is Spirit a practical robot for learning, he's also loaded with personality. He has a pan-tilt head to look around and tell you how he's feeling. 27 NeoPixel-style lights can be individually controlled to create any color sequence you can think of, and a piezo sound chirper can create blips and tones. These are the droids you're looking for. The Raspberry Pi camera can be used for computer vision. This is an exciting new field in robotics. Spirit can identify objects, colors, movement, and even faces. The rover includes a gripper along the front, suitable for moving and collecting small objects. Spirit can see the gripper and object with his camera, so remote controlling and computer vision operations are possible. Spirit includes several useful navigation sensors in addition to the camera. The eyes are actually an ultrasonic rangefinder that measures distances to objects. The main board also includes a 3-axis accelerometer and gyroscope. These sensors can be used to move specific distances and make accurate turns. An array of bottom sensors are also provided that can be arranged in various patterns. The sensors can follow lines or sense edges. You can also enable an emergency stop, where the motors will automatically stop if the robot's about to fall off an edge. 3 ambient light sensors are provided to measure light 360 degrees around the robot. We've also included a port to add an optional LED headlight or infrared emitter for communication or navigation in the dark. Spirit is actually 3 computers in one. The Raspberry Pi at the heart of the rover will handle most of your code and processing. The Arduino-compatible processor on the rover's main board can be used to run code by itself or used together with the Pi. The third processor is a microchip PIC processor. It's preloaded with code and handles low-level tasks in the background. You can hack it too if you like. All 3 processors communicate with each other using simple functions, allowing you to effectively control any of the robot's hardware and sensors in almost any conceivable combination. This is truly a hacker's dream robot. You can communicate, upload code, and drive the rover remotely from just about any computer or smartphone using Wi-Fi or Bluetooth, including common 6-axis type game controllers. You can even program and remote pilot the robot over the internet. Use Wi-Fi or Bluetooth built onto the Pi, or add your own module to the main board for Wi-Fi, Bluetooth, and even XBee for Zigbee mesh networking. The robot is powered by a single-cell battery with a runtime of 1 to 4 hours. Automatic charging is built right in. The robot can be powered or charged from a USB cable connected to your computer or an optional external wall power supply. We should also point out Spirit's high-quality components. The micro gear motors are precise and allow the robot to run on a variety of surfaces. The plastic frame parts are made from semi-flexible ABS plastic. The parts are not brittle, so you won't have to worry about them cracking. The rest of the hardware includes durable parts stamped from metal, striking a good balance between lightweight and durability. You'll assemble Spirit yourself from a kit using common hand tools. No soldering is required, and we'll provide illustrated instructions to make the process easy. Spirit is a great solution for so many applications, from basic remote control toy, to learning simple and advanced coding, to learning how autonomous robots work at a deeper level. You're not going to get bored with this robot anytime soon. Easy access is provided to connect to monitor and USB devices. You can use the Raspberry Pi inside the Spirit just like you would a normal standalone Pi. All the important signal lines and ports are exposed so advanced users can add on to the robot or use the electronics on their own custom robot frame or chassis. We'll guide you along the way through written guides and tutorials along with examples you can customize on your own. For the past 2 years, we've been creating an ecosystem of robots and guides to teach programming. Continuing with this effort, we also plan to launch a YouTube series covering all kinds of tutorials and inspiring examples for Spirit and our other robots. This project is not officially endorsed or affiliated with NASA, JPL, or any of the agencies related to the actual Mars missions, but I am a huge space nerd. This project is a salute to the extraordinary engineers at Jet Propulsion Laboratory, NASA, and the rest of the world's space agencies. By backing this project, you'll help us buy parts in larger quantities and cover the tooling costs for Spirit's custom parts. You'll also help educate and inspire the rover designers of the future. We'll add another awesome robot to our lineup and continue in the spirit of the open source movement to share and freely educate. Thank you for your time, and thank you for your support.